All right, so today we're going to be looking at activity 11. We're going to be looking specifically at lesson 11.1, dealing with congruent triangles. So we're going to start off by looking at some trusses. Greg Carpenter works for the Green Construction Company. The company is building a new recreation hall, and the roof of the hall will be supported by triangular trusses, like the one shown below. So if you've ever seen a building as it's being constructed that has a roof that's at an angle, you may have seen a truss. It's just the support of the roof structure. It is in the shape of a triangle, and it's going to usually be built from wood or steel. If you have a flat roof, then you wouldn't have a truss. But if you have a house that has an angled roof or a building that has an angled roof, you would see a truss there. So, each of the trusses contains pairs of congruent triangles. Greg's boss tells him that his first job will be to determine the side lengths and the angle measures in the triangles that make up one of the trusses. And as you can see, the trusses have a lot of different triangles. We're not going to want to measure all of them. We want to try and do our work more efficiently. So we're going to see if we can figure out how to measure fewer triangles and use that information to find the side lengths and the measures of all the angles for one of the trusses. So a truss uses triangles specifically because they are strong and rigid, because their angles and sides do not change under pressure. So that's why they're going to use triangles a lot in construction. So let's look on the next page. Greg wants to know, if I know that two triangles are congruent and I know the side lengths and angle measures in one triangle, do I have to measure all of the sides and angles in the other triangle? So pause the video for a second. Consider that statement, that question. What do you think? No, you're not going to need to measure all of the sides and angles in the other triangle. So since the triangles are congruent, we have pairs of sides and angles that are congruent. And so since we know the side lengths and the angle measures of one triangle, the other triangle is going to end up having some of those same side length and angle measures. And so that's what we're going to be looking at today. How can we determine exactly which ones match up? So Greg begins by examining two triangles from the truss, triangle ABC and triangle FED. And the manufacturer tells us that the two triangles are congruent. So, looking at number one, because the two triangles are congruent, can one triangle be mapped onto the other? And if yes, what are the criteria for the mapping? So yes, the triangle could be mapped to the other one by using some sort of rigid motion, or maybe a sequence of rigid motions. So that'd be a translation or a rotation or maybe a reflection. So, yes, that is going to happen because we know our transformations that we've looked at are rigid motions. And so if they are congruent, there is going to be some rigid motion that we can use to map one triangle to the other. So see if you can decide what type of transformation appears to map one triangle to the other. If you need to pause the video to think about it, you can. But hopefully you're coming up with that it's a reflection. And the line of reflection is somewhere in between point C and F. It's a vertical line somewhere. Should be exactly halfway between point C and point F. So let's look at number two. We are going to use our rigid motions to map ABC onto DEF. And then we want to find the image under the transformations. So if we take this figure and we reflect it over here, we are wanting to identify what sides end up matching together. So it's actually sometimes easier to start with the angles, but maybe you might like the sides. So if you want to do the angles first, you can. We're going to look at this side. It's going to map to that side over here, ED. But now, when we're dealing with these types of problems, the order is going to make a big difference. So you need to make sure to look, is it ED or DE? Well, they give us specifically AB. So A is going to map to D. So if A is first here, D is going to have to go first whenever I'm looking at the image. And then if B is second, B maps to E. And so we know that AB is going to map to side DE. Then side BC is going to map to this side. And we just said B maps to E, so we know we have to have E first. And then C is going to map to F. And then the last side, AC and FD are going to map. Specifically though, AC is going to map to DF. And then if you look at your angles, angle A is going to map to angle D. Angle B is going to map to angle E. And angle C is going to map to angle F. So if you're looking at number 3, what is going to be the relationship between side AB and DE? And what's the relationship between angle B and angle E? And how do you know? Well, we know that AB is going to be congruent to DE. And we also know angle B is going to be congruent to angle E. And that's because using some sequence of rigid motions, using our reflection on this particular one, we had a mapping of AB to DE. And by the same rigid motions, we had a mapping of angle B to angle E. And so that's how we know that they are congruent. So that brings us to this next part. Talking about a new term, corresponding parts. So the triangles that we were just examining from the truss are going to illustrate an important idea about congruent triangles. In your congruent triangles, in every pair of congruent triangles, if you know you have congruent triangles, your corresponding pairs of sides are going to be congruent. Likewise, your corresponding pairs of angles are going to be congruent. And those are your corresponding parts. So if I go back up to this figure for just a moment, angle A corresponded to angle D. And so that means that angle A is congruent to angle D. Because we know we have congruent triangles, we know A and D are corresponding. And that means that we have corresponding parts, and that means they have to be congruent. So corresponding parts are the pairs of matching sides and matching angles that are identified when you take one figure and you map it to the other. When you take one figure and you transform it so that its image is the other figure. Whenever your figures are congruent, their corresponding parts are also congruent because there is a sequence of rigid motions. There's a sequence of transformations that map each pair of corresponding sides and angles to each other. So let's look at this congruent statement here. Triangle ABC is congruent to triangle DEF. So when you write statements like that, the corresponding parts have to be in the same order. They absolutely have to be in the same order. So if you look here, A comes first, D comes first, from the left side to the right side. That means that angle A must be corresponding to angle D. And since the triangles are congruent, I can say angle A is congruent to angle D. Likewise, B comes second and E comes second. That means angle B and angle E are corresponding because they're in the same order. They're both second on our statement. So angle B must be congruent to angle E because our triangles are congruent. And by the same logic, C and F are the third in line, and so angle C has to be congruent to angle F. And then you can use the same idea with your side lengths. So side BA must be congruent. So B is second, A is first. It must be congruent to ED. Notice they put it in a different order. They said AB, then they have to say DE. The order makes a difference. If I said side CB, it would be congruent. B is the second one, and C is the last one. So I said 3 and then 2. So then it would be congruent to 3 is F and 2 is E. And again, they did it in a different order. So both of their sides have to be in a different order than what I have. And then if I look at side CA, it would be congruent to side FD. And so you can always look at your congruent statements and set up your congruent corresponding parts. So now let's look at the next page. They give us a truss, and we know, based on this congruent statement, that triangle JKL is congruent to triangle MNP. So we have triangle JKL and MNP. And we want to know if we have any additional lengths or angle measures besides the two that are given. So they tell me that I have 2.1 meters for side LK, and I have a 50-degree angle here for angle N. Since our triangles are congruent, we can look, JKL has one side length of 2.1, and so that side length KL. So KL is going to correspond to NP, which means that they have to be congruent. And so if KL equals 2.1 meters, that means that NP is also going to equal 2.1 meters. And so that's what this sentence says. Likewise, by the angles, we know angle N equals 50 degrees. So N and K correspond. So angle K is going to be congruent to angle N. So if I know angle N is 50 degrees, that means that angle K is also going to measure 50 degrees. So I know this side length, I know this angle, I know this angle, and now I know that side length. But do you see how I don't know the other two side lengths or the other two angles? And sometimes that's what will happen. You may know some of the sides and angle measures for your congruent triangles, but it's not going to always be possible to determine all of the measures. So you may not be able to find all of them. And that's what they're wanting us to look at in these next few problems. In our figure, they tell us triangle RST is congruent to triangle XYZ. So the first thing you want to do is to identify your corresponding parts. So angle X is first on the right side. So on the left side, R is first. So the measure of angle X is going to be congruent to the measure of angle R. And if you look, we don't have the measure of angle R, so we can't find the measure of angle X. If you look at C for the measure of angle T corresponds to angle Z. And if you look, we know the measure of angle Z is 47. So that means that the measure of angle T is going to be 47 degrees. Then if you look at side YZ, YZ corresponds to ST. We know that ST is 15 centimeters, so that means that YZ is also going to equal 15 centimeters. Looking at D, XZ is going to be congruent to RT because those correspond. So if you look up here, X and Z are your first and your third. And so our first and our third are R and T. But we don't know the measure of side RT, so then we can't find the measure of side XZ. If you're wanting to use a manipulative to look and see if you can help determine the sides that are corresponding and the angles that are corresponding, if looking at the order in your congruent statement up here is confusing to you, you could use patty paper to trace one of your triangles and then rotate, reflect, translate it somehow so that they map onto the other triangle. And so you could rotate or turn or reflect it or just slide it over, and you could put it so that your triangles are exactly on top of each other, and then you would be able to tell which sides are corresponding because the corresponding ones will be right on top of each other. And so if you need help with that, use your patty paper. So, part E, both triangle JKL and triangle MNP are equilateral triangles in which the measure of each angle is 60 degrees. Can you tell whether or not triangle JKL is congruent to triangle MNP? So you may want to pause the video and think about this one for a second. If I know that I have an equilateral triangle and my angle measures are 60 degrees, there's one of my triangles. So that could be maybe triangle JKL. Does it have to be congruent to triangle MNP? Well, this is a 60-degree angle. This one's 60 and that one's 60. That's still possible. But this side is not congruent to this side. This red triangle is an equilateral triangle, but as you can tell, my two triangles are not the same size and shape. They are the same shape. They're both equilateral triangles, but they're not the same size. They have different side lengths. So no, those triangles are not going to necessarily be congruent. Your equilateral triangles have to have the same angle measures, but they could have different side measures. This one that's blue could have side lengths that measure 10, and this one that's red could have side lengths that all measure 20. Your corresponding sides are going to be proportional, so this side is corresponding to this one, and it's, if you look at a fraction, 10 over 20 is 1/2, and all of the sides are going to be in that same proportion, but that doesn't mean that the side lengths are equal. So that means that the triangles may not be congruent. Is it possible that they are? Absolutely. But that doesn't mean that they will have to be. So if you look, there's one triangle. And if I clone it, those two triangles right now are identical. They are congruent. But when I look at this bigger triangle, obviously the sides are thicker, but this angle measure is the same as that angle measure. This angle measure up at the top is the same as that angle measure. And then this angle is the same as that angle. And so my angles match up, but those are not congruent triangles. So, question to make you think, what additional information would you need to be able to find the other missing measures? If I knew that my angles were 60. So let's say I have a triangle here and all of the angles are 60, and I have a triangle here and all of the angles are 60. What would I need to have to show that triangle 1 and triangle 2 are actually congruent? I would need a side length, and that's what we're going to be getting into in the next few lessons. So let's go to the next page and look at number 4. If two triangles are congruent, can we conclude that they have the same perimeter? Why or why not? If you want to pause the video and work through these, go ahead. I'm going to go over what you should be thinking about them. So yes, you can conclude that they do have the same perimeter. Congruent triangles have the same side lengths. They have the same measures for their side lengths. Perimeter is finding the sum of your side lengths. So since they have the same side lengths, the sum of their sides, the perimeter is going to be the same. For number 5, is it possible to draw two congruent triangles so that one triangle is an acute triangle and one triangle is a right triangle? Why or why not? No. And the reasoning, congruent triangles are going to have the same angle measures. All of the angles for an acute triangle are going to be an acute angle, which means they're going to be less than 90 degrees. For your right triangle, one angle is going to be a right angle. And so since one angle of your right triangle is a right angle, the angles of your two triangles are not going to be able to have the same measure. So that means that your triangles cannot possibly be congruent. Now let's look at number 6. So on this, we have a rectangle that's divided into two congruent right triangles by your diagonal AC. And we want to fill in our missing congruent sides and angles. So I'm going to start by figuring out which sides and angles map to the other. So you may want to try and do this with patty paper, or you may just be able to visualize it. But trace one of them, and what it's going to end up being is a rotation that's going to map them onto themselves. So this top left angle is currently angle A, and when I turn it, it gets put on the bottom right. By the same idea, when I move my triangle, I turn D, it's going to get mapped up here, and then the angle up here is going to be angle C. And so when you're doing your patty paper, it may help you to label your vertices before you rotate it so that you can make sure you put them in the correct order. So if AB is congruent, based on my figure, it's going to be congruent to side CD. And BC is going to be congruent to side DA. And so those two are maybe a little bit easier to look at compared to the angles. And so what I want to do before I try the angles is to go over. On this triangle, I have angle A, angle B, and angle C. Angle B is the right angle, and angle D is the other right angle in my left and bottom triangle. So angle B is going to be congruent to angle D because they correspond. Now, what's interesting, when you rotate it, angle A and angle C are going to actually end up being congruent, and then angle C and angle A are going to be congruent. So angle A is not congruent to angle A, and angle C is not congruent to angle C. They end up getting moved, and they map to the other one. So then, when you're looking at this ordering, angle B gets mapped to angle D, and then A gets mapped to C, and C gets mapped to A. By the same logic, angle A, C, B, so A, C, B gets mapped to angle C, A, D. And so that would be what you would have for number 6. For number 7, they don't give you a figure, but you don't have to have it. You can just look at this congruent statement, and you look at the order and the placement of your letters. So QR is going to be congruent to HJ, and then GJ is going to be congruent to PR. And then angle R is going to be congruent to angle J, and angle G is going to be congruent to angle P. If it helps you to draw your triangles, you absolutely can on those. So now let's look at the lesson practice. We want to find the length of AB. So if you look here, AB corresponds to DF. So we know, based on the figure, that DF is 18. So that means that AB is also 18 inches. For number 9, we want to find all of the possible angles that we can here. So if you look at the triangle on the left, there is only one angle that we're given, and that's 39 degrees for angle A. So angle A corresponds to angle D. So that means that the only angle we can find is angle D, and it's going to measure 39 degrees because it corresponds to angle A, and they are congruent. For number 10, the perimeter. Perimeter is adding up all of the side lengths. What is the sum of your sides? So we know that one side is 22, one side is 18. The side ED corresponds to the side CA. And so if CA is 33, ED is also going to be 33 inches. So when you find your perimeter for number 10, 33 plus 22 plus 18 gives you a total of 73 inches. Looking at number 11, if we know that our triangles are congruent and XY is the longest side, is it possible to determine which side of triangle TUV is the longest? And explain. Yes, if we know our triangles are congruent, XY corresponds to TU. And so since those are corresponding, if XY is the longest side of one triangle, TU is going to be the longest side of the other triangle. And so that's how you know the side that's going to be the longest. So hopefully that helps you a little bit with lesson 11.1, dealing with congruent triangles.